Welcome to my little corner of the internet, where we celebrate creativity and growth. Welcome, curious minds, to our video that explores the ins and outs of 1956 Atlantic hurricane season. The 1956 Atlantic hurricane season featured a decent number of tropical cyclones, although most tropical storms and hurricanes affected land. There were 12 tropical storms, the third of which became hurricanes. One of the hurricanes strengthened to the equivalent of a major hurricane, which is a Category 3 or greater on the Saffir-Simpson scale. The strongest hurricane of the season was Betsy, which was also the most damaging storm of the season. It destroyed 15,000 houses and left $40 million in damage in Puerto Rico. Geographical damage figures in the article are in 1956 United States dollars. US group, and Betsy was also the deadliest of the season, having killed 18 people in the French West Indies, 2 from a shipwreck in the Caribbean Sea, and 16 in Puerto Rico. Tropical Storm Dora struck Mexico in September and killed 27 people. The season officially started on June 15, although an unnamed storm developed about a week prior over the western North Atlantic Ocean. A later storm that formed over the Gulf of Mexico on June 12 alleviated drought conditions in the south-central United States. Hurricane Ana developed in late July and hit Mexico. Tropical storms Carla and Ethel both formed near the Bahamas and moved northeastward until dissipating. The only hurricane that hit the contiguous United States was Hurricane Flossie. One of the final storms of the year, Greta, was an unusually large hurricane that produced high waves from Florida to the Lesser Antilles. It developed in the western Caribbean and moved across much of the southeastern United States, causing $24.80 million in damage and 15 deaths. Brace yourself for an in-depth analysis as we navigate through season summary and its far-reaching implications. The season officially began on June 15, the date that the Weather Bureau office in Miami, Florida, under the direction of Gordon Dunn, began day monitoring of all tropical disturbances and cyclones across the northern Atlantic Ocean. The agency had access to the Hurricane Hunters, a fleet of aircraft that obtained data by flying into storms. The Weather Bureau, in collaboration with other agencies, began a 5-year project in 1956 to obtain and analyze data on the structure of hurricanes. The season officially ended on November 15. There were a total of 12 tropical storms during the season, 5 of which were unnamed. In all, 4 storms strengthened into hurricanes. Compared to the average activity from the previous 2 decades, the season's activity was below normal despite average sea surface temperatures and a normal number of tropical waves. A tropical wave is an elongated low-pressure area that originates in Africa and moves westward across the Atlantic Ocean. Some tropical waves develop into tropical storms or hurricanes. Instead, the inactivity was the result of the subtropical ridge being located further south than normal, which decreased the atmospheric instability across much of the basin. Such a pattern was different from the more active 1954 and 1955 seasons. Several tropical depressions formed that did not attain tropical storm status, many of which formed beneath an unfavorable upper-level trough. The season's activity was reflected with a cumulative accumulated cyclone energy ACE rating of 54, which is categorized as being below normal. ACE is, broadly speaking, a measure of the power of the hurricane multiplied by the length of time it existed, so storms that last a long time, as well as particularly strong hurricanes, have high ACEs. ACE is only calculated for full advisories on tropical systems at or exceeding 34 kN or tropical storm strength. Thus, tropical depressions are excluded from the total. Turning our focus to early June tropical storm, let's explore its key elements. A dissipating cold front off the southeastern United States spawned a low-pressure area on June 6. On the next day, the system organized into a tropical storm off the coast of North Carolina. The storm moved southward and reached peak winds of 45 miles per hour, based on reports from ships. During its duration, the storm failed to develop an inner core, affected by cool, dry air to the northwest. The structure was likely akin to a subtropical storm, based on its formation beneath an upper-level trough. On June 8, the storm accelerated to the northeast ahead of an approaching cold front, weakening to a tropical depression the next day, and becoming an extratropical cyclone within the front on June 10. The system dissipated later that day as a larger storm developed within the front. In the next portion, we'll be immersing ourselves in the realm of mid-June tropical storm and examining its broader implications. During the second week of June, a tropical wave traversing the Yucatan Peninsula commenced interacting with a trough extending from the Gulf of Mexico to the western Atlantic Ocean, which generated a disturbance over the Bay of Campeche that spawned a tropical depression on June 12. The newly developed tropical cyclone tracked northward, quickly intensifying into a tropical storm. It attained peak winds of 60 miles per hour on June 13, although it never developed a well-defined circulation. In addition, it had characteristics of both a tropical and extratropical cyclone, with cooler air aloft. Late on June 13, the storm made landfall near Cocodrie, Louisiana, and its lowest pressure of 1001 was measured over land, suggesting it did not weaken substantially after landfall. After moving inland, it dissipated on June 15 over Arkansas. As the storm moved ashore, it did not develop rainbands, unlike other tropical cyclones. The heaviest rainfall occurred in a 100 miles region east of where it moved ashore. Precipitation fell across the entire United States Gulf Coast, and the highest rainfall total was 8.89 in Golden Meadow, Louisiana. The rains were beneficial to farmers due to drought conditions persisting in the region. The storm produced higher than normal tides, peaking at 4.7 foot in Biloxi, Mississippi. This was the highest since the 1947 Fort Lauderdale hurricane. The tides left damage to the Freeport Sulphur Company, as well as to boats, beaches, and piers. 3 people died after their boat capsized, and there was another death after a driver skidded off the Lake Pontchartrain causeway. A barge in the lake became disabled due to the storm and caused light damage to the causeway. Sustained winds during the storm's passage peaked at 55 miles per hour near Grand Isle, Louisiana, and a boat reported a gust of 60 miles per hour near Pillartown, Louisiana. Damage was estimated at $50,000. Now, we shift our focus to Hurricane Ana, a topic that deserves our attention. A westward-moving tropical wave traversed the Lesser Antilles on July 20. It moved across the Caribbean, and its thunderstorms increased on July 23 while passing south of Cuba and beneath a high-pressure area. There is evidence that it could have developed a circulation on July 24 before it struck the Yucatan Peninsula. It is confirmed to have developed into a tropical depression on July 25 in the Bay of Campeche. As it continued west-northwestward, it rapidly intensified into Tropical Storm Ana, and before moving ashore in Mexico near Azuloma, Veracruz, on July 26 it attained hurricane status. Peak winds reached 85 miles per hour, although Ana rapidly dissipated on July 27 as it moved further inland. The high winds wrecked several homes in poor regions of Tampico, Tamaulipas, while rainfall of 2.5 in resulted in flooding. The high winds severed telegraph lines from Tampico to San Luis Potosí. The same area was affected by several hurricanes in the previous year. Damage totaled around $50,000, and there were no deaths. In this section, we'll be peeling back the layers of Hurricane Betsy to reveal its true essence. A tropical wave moved off the coast of Africa on August 4. It developed into Tropical Storm Betsy, developed on August 9 to the east of the Lesser Antilles. It rapidly developed into a 105 miles per hour hurricane before striking Guadeloupe with a minimum central pressure of 979. There, Betsy heavily damaged 1,000 houses and left severe crop destruction, and led to 18 deaths. As Betsy continued into the northeastern Caribbean, it capsized a ship, killing its crew of 2. On August 12, a slightly weakened Betsy struck southeastern Puerto Rico near Manabo with winds of 100 miles per hour and quickly crossed the island. Damage was heaviest where it moved ashore and in the territory's central portion. 15,023 houses were destroyed by Betsy, and multiple locations reported heavy crop damage, including Cami, which reported a complete loss of the corn crop. After exiting Puerto Rico, Betsy strengthened steadily as it headed generally northwestward, becoming a major hurricane on August 13 while centered north of the Turks and Caicos Islands. It attained peak winds of 120 miles per hour the next day to the east of the Bahamas. Betsy later turned northeastward, attaining its lowest central pressure of 954 m on August 17. It later became extratropical early on August 18. The remnants dissipated 2 days later to the north of the Azores. Hurricane Betsy was the first hurricane to be observed from the San Juan radar, and also resulted in the first hurricane warning on the island that was released on television. The hurricane left $40 million in damage and 16 deaths, which prompted the declaration of a federal disaster area. Locally, the hurricane was known as the Santa Clara Hurricane. Without wasting any more time, let's jump into the fascinating world of Tropical Storm Carla. The origins of Tropical Storm Carla were from a tropical wave that spawned a depression near the Bahamas on September 7. It moved generally to the north, intensifying to a tropical storm the following day. An upper-level low located to the northeast of Carla produced hostile conditions that prevented significant strengthening, and Carla had a structure which resembled a subtropical storm. An approaching cold front turned the storm to the northeast, and despite the unfavorable atmosphere, Carla intensified, reaching peak winds of 60 miles per hour 95 late on September 9. The interaction between the storm and a high-pressure system over the Great Lakes yielded a strong pressure gradient that produced gale force winds over New England. After Carla passed to the north of Bermuda, it became extratropical on September 10, according to HUD's official hurricane database and the annual report in the monthly weather review. As a post-tropical cyclone, Carla strengthened to 70 miles per hour before weakening and dissipating by September 16. Now, let's delve into the intricacies of Tropical Storm Dora and explore its various aspects. On September 10, a tropical depression developed over the Bay of Campeche. Later that day, hurricane hunters observed winds of tropical storm force, indicating that the depression had become Tropical Storm Dora, with winds of about 40 miles per hour. Dora moved generally westward due to a ridge to its north. A reconnaissance flight on September 11 estimated hurricane force winds, but reanalysis assessed these as being unrepresentative of Dora's true strength. Early on September 12, Dora peaked at 60 miles per hour shortly before striking land near Tuxpan with a minimum central pressure of 1,000 m. It quickly dissipated early the next day, although the storm produced heavy rains across the region. The deluge caused a landslide as well as flooding, including along a river near San Andres Tuxtla. In Puebla, there were 13 deaths and 20 injuries after a bus crashed into a washed-out portion of the highway from Tuxpan to Mexico City. Overall, Dora caused 27 deaths in the country, but minor damage. Brace yourself for a deep dive into Tropical Storm Ethel as we explore its impact and relevance in our evolving narrative. On September 11, a tropical depression developed along the southern end of a quasi-stationary cold front over Grand Exuma Island in the Bahamas. It moved to the northeast and encountered cold air from the north. This resulted in significant instability that allowed in quick strengthening. A hurricane hunter's flight on September 12 reported winds of 76 miles per hour in the storm's northeast quadrant. As a result, the depression was upgraded to Tropical Storm Ethel. The flight observed a well-developed eye 20 miles in diameter, although they only observed hurricane force winds in one quadrant. Reassessment, however, discounted the observations of hurricane force winds from the aircraft as being unrepresentative of Ethel's strength, and analyzed that Ethel peaked at 60 miles per hour late on September 12, with the lowest pressure reported being 999 m. Shortly after reaching peak intensity, Ethel began weakening and dissipated on September 14 to the southwest of Bermuda. As we progress through this video, let's shift our attention towards Hurricane Flossie and uncover its hidden depths. Hurricane Flossie originated from a tropical wave that moved through the Caribbean. A tropical depression formed on September 20 just east of the Yucatan Peninsula and headed northwest across the landmass. Upon entering the Gulf of Mexico on September 22, it quickly intensified into Tropical Storm Flossie. Continuing to intensify, the storm turned to the north and attained hurricane status on September 23. Bearing winds of 85 miles per hour, Flossie struck near Venice, Louisiana, on September 24 after turning to the northeast, crossing the Mississippi River Delta. The hurricane again moved into the Gulf of Mexico, continuing to the northeast and intensifying further until moving ashore near Miramar Beach, Florida, on September 25 as a strong Category 1 hurricane with winds of 90 miles per hour and a minimum pressure of 974 mPa. Later that day, Flossie became extratropical over Georgia after weakening into a tropical storm. The extratropical remnants moved through the southeast United States and emerged from North Carolina into the western Atlantic on September 27. The storm was last observed on October 3, near southernmost Newfoundland. Flossie was the only hurricane of the season to strike the United States. Winds in Louisiana reached 84 miles per hour, although an oil rig offshore Grand Isle reported a gust of 95 miles per hour. The storm dropped heavy rainfall along its path, peaking at 16.7 in Golden Meadow, Louisiana. The rainfall and the hurricanes accompanying the storm surge caused widespread flooding and beach erosion in southeast Louisiana. The flooding surmounted the eastern seawall in New Orleans, submerging an area of 2.5 sq.mi. Across the region, the resulting flooding drowned cattle and caused heavy crop damage. Hurricane Flossie left about $27.80 million in damage 1956 USD, mostly from crop damage, as well as 15 deaths. The rainfall extended through the mid-Atlantic states, which alleviated drought conditions. Now, let's delve into the intricacies of early October tropical storm and explore its various aspects. A tropical wave exited the west coast of Africa in early October. By October 9, a tropical storm developed with winds of 45 miles per hour, based on ship reports. On October 10, the storm turned to the north and weakened to a tropical depression. It drifted northeast for 2 days, dissipating on October 12. With the groundwork laid, let's now examine mid-October tropical storm and its connections to our previous discussions. A low-pressure area formed along a dissipating cold front to the north of Puerto Rico. The system moved westward, developing some tropical characteristics by October 13. The next day, the system became a tropical storm over the Straits of Florida. On October 15, it crossed over South Florida near Homestead with winds of 60 miles per hour. While it is unclear whether this cyclone ever became fully tropical, it is entered into HURDAT as a tropical cyclone. The storm intensified further over the Florida peninsula, peaking at 65 miles per hour early on October 16. After affecting Florida, the storm crossed the western Atlantic and moved across the Outer Banks. The storm became extratropical on October 17, and the next day it was absorbed by another extratropical storm. The storm produced significant rainfall in a 50 miles region of Florida. The highest total in the state was 16.28 in Kissimmee. There, the rains caused flash flooding that entered over 200 houses. The flooding flooded 3 state highways, and also left portions of Okeechobee inaccessible after reporting the heaviest rainfall in 8 years. Large tomato fields were inundated, resulting in some crop damage. In portions of the state, the rains were beneficial due to previously dry conditions. The storm spawned a tornado in North Miami that injured 1 person. Damage throughout Florida was estimated at $3 million, mostly in the Kissimmee area. In addition, 2 surfers drowned during the storm. Precipitation extended as far north as New Jersey, and coastal areas experienced high tides and gusty winds. In the next phase, we'll be immersing ourselves in the realm of Hurricane Greta and exploring its real-world applications. The Intertropical Convergence Zone spawned a tropical depression on October 31, a short distance to south of easternmost Cuba. The system tracked northward and crossed over eastern Cuba, and the system initially had characteristics of an extratropical cyclone. It eventually acquired tropical features and intensified into Tropical Storm Greta on November 1. A high-pressure area east of the mid-Atlantic states caused the depression to turn to the south on November 2 and loop to the southeast. Later that day, the depression intensified into Tropical Storm Greta to the northeast of the Bahamas. It attained hurricane status on November 4 while maintaining a large size, in fact, becoming one of the largest tropical cyclones known in the Atlantic basin. Such strengthening is unusual in storms moving in a southeast trajectory. Greta turned to the east and later northeast, reaching its peak of 100 miles per hour late on November 4 due to the energy transfer between levels of the atmosphere. Cooler waters caused subsequent weakening and gradual loss of tropical characteristics, and Greta transitioned into an extratropical storm on November 6, dissipating the next day. The extremely large size of Greta, in conjunction with the high-pressure system to its north, produced strong winds and high waves across a large area of the western Atlantic. In Puerto Rico, waves of 20 foot left heavy damage and killed one person who did not heed an evacuation order. Waves reached 25 foot in the French West Indies, which destroyed 80% of the structures at the port in Basse Terre, Guadeloupe. Further west, high waves left heavy damage in and around the beaches of Jacksonville, Florida. Overall damage was estimated at $3.58 million. Let's now zoom in on November tropical storm and uncover the hidden gems that lie within. In the middle of November, a weakening cold front produced a low-pressure area, which organized into a tropical depression early on November 19, though it is possible it formed a day earlier. The depression moved slowly west for the next 12 hours, becoming a tropical storm thereafter. Due to its slow movement, and based on ship reports, it is estimated that peak winds were 45 miles per hour, with a minimum pressure recorded was 1,002 bar. The system continued to crawl westward, weakening to a depression on November 21 at 12 UTC and degenerating later in the day to a trough of low pressure. Now, we shift our focus to other systems, a topic that deserves our attention. A weak circulation developed late on July 4 beneath a cold mid-level trough in the Gulf of Mexico. It moved north-northwestward and hit near Pensacola, Florida, on July 6. It dissipated on July 7. Although the disturbance did not generate gale-force sustained winds, it produced wind gusts of 47 miles per hour in Panama City, Florida. As it moved ashore, the system dropped heavy amounts of precipitation, with a total of 14.22 reported in Watley, Alabama. The rains washed away or eroded several highways and bridges, and also resulted in some agricultural damage. A train line from Mobile to Birmingham, Alabama, was washed out near Suggsville. Overall, the damage was estimated at $503,000, and there were no associated deaths. A vigorous tropical wave spawned a possible tropical depression on August 28 near the Cape Verde Islands. A weather station on the island of Sal recorded a minimum central pressure of 1,004 bar on August 31. Ships in the area reported winds as strong as 46 miles per hour as the storm moved through the islands. However, the ship and land data was insufficient to establish whether the system had developed a closed low-level circulation. It maintained a general westward track, eventually dissipating on September 6 to the northeast of the Lesser Antilles. In this part of the video, we'll be delving deeper into storm names and analyzing its key components. The following list of names was used for named storms, tropical storms, and hurricanes that formed in the North Atlantic in 1956. This was a completely new set of names, thus every name used this season was used for the first time. I'm here to provide you with the best information, so let me know what else you'd like to learn about.